Hello, I'm Mary Ito, and welcome to the CRAM podcast. CRAM is an acronym for Communicating Research and More, which is what we try to do on this podcast. A lot of exciting research and groundbreaking ideas never reach the public, but they have the potential to change the way we think and act. So, how is it that a bunch of sounds grouped together in a certain manner can bring me to tears? And those same sounds, grouped in a different way, can fill me with indescribable joy. That is the power of music. But how does music soothe the savage breast, as playwright William Congreve noted? And why does music give soul to the universe, wings to the mind, and flight to the imagination, as Plato believed? Robert Zatorre has spent much of his life trying to solve some of the mysteries of music by studying its effects on the brain. He's received many awards and honors for his work as a cognitive neuroscientist. Professor Zatorre is with the Montreal Neurological Institute at McGill University, and he joins us. Hello, Robert.
Hello, Mary.
I was really intrigued by a talk that you gave a while ago. And in this talk, you described a memorable moment in your youth when you came across a piece of music. And I wonder if you could share that with us.
Sure, yeah, this was, one of those kind of epiphanous moments that people often have when they're young and in adolescence. Um, and in this case, it was very transformative for me personally because I had never really been exposed to a whole lot of complicated new music. At the time, I must have been, I don't know, probably 13 or 14. And I was listening to rock music. This was back in the 60s and 70s. Um, like all my friends, I was just listening to I don't know, bands that people have forgotten now, like Iron Butterfly or things like that. Um, and one day, I somehow got my hands on a record. This was in the days when we still had vinyl records, and it was a piece of music by Bela Bartok, the Hungarian composer. And I had never heard of Bela Bartok. I had no idea what it was. I just put it on just to see what it was. And I was completely transfixed. I just had never experienced anything quite like it. And it just gave me, a very profound appreciation for how music could make you feel. And I have to admit that, previously I had listened to music and I thought I liked it, but I had not had this kind of, very deep emotional experience. And we can actually listen to a little clip of it if you'd like.
Yeah, okay.
So, that's only an excerpt of a much longer piece. It doesn't quite do it justice.
Mm-hmm. And of course, you're not alone in deriving huge pleasure from music. So many people derive pleasure from music. How is it that this happens? How is it that we get pleasure from listening to music?
Yeah, well, we've been showing that one for the last 20 or more years. Um, and I think we have the beginnings of a reasonable answer. And there are um, different components to that answer. So the first point, because I'm a neuroscientist, is to try to understand the brain basis for this response. So when you look to see how does um, how does pleasure work in the brain, there is a big literature on pleasure and what we call hedonic responses, um, which is mostly about the reward system. So the reward system is this set of structures in the brain. It's a whole circuit of complicated brain regions, which is basically there to signal uh, salient, important, and pleasurable events. And the way that it's been typically studied is with what we might call primary reinforcers. or biologically meaningful stimuli. The most obvious example is that if you take an experimental animal like a rat and you give it food when it's hungry, you will see that neurons in its reward system are active when it receives the food. And those neurons are dopaminergic, means that dopamine is the neurotransmitter that's involved. And there are a lot of subtleties to the reward system because it not only responds to the reward itself, but it also responds to the anticipation of the reward. So if the animal is cued that food is going to arrive, its reward system will also be active. And for decades, this kind of research went on with these sort of biological stimuli, like food, like water, like warmth if you're cold, or cool if you're hot.
Hmm.
These kind of things that have to do with homeostasis, if you will, with maintaining the body in a healthy state. If you're hungry,
Right.
you need food. If you're thirsty, you need water. If you're cold, you need warmth. And then
And
the
what
other
about
big,
sex? Would sex also be part of that? Right?
absolutely. So the other
Yeah.
big component of that is sexual stimuli, because sexual stimuli strongly excite the reward system. And if it were not so, the species would fail to reproduce. And so it's necessary for survival in that sense, although any given individual may or may not have that opportunity. So when we first started doing research on music, we said, okay, we know this huge literature on the neurophysiology of reward, but then we have music, which is not really biologically necessary. Like, you can live
Hmm.
without it. You won't die. Um, and it's not, it's not a physical substance.
Right.
It's not a drug, because drugs also, by the way, things like cocaine activate the reward system, which is why they're so dangerous, because you can become addicted. But that's a direct chemical action, right? Music is not a chemical. And then there are other things like money, for example. Money is also a reward and does activate the reward system. But money
Oh,
has like a learned association. In other words, we find money rewarding because we can use it to buy stuff, right? It's fungible in
right.
economic terms. But
Right.
music is not like that. We don't listen to music because we can then use the music to get food or something. It doesn't really
Yeah.
work.
Yeah. True.
So, more than 20 years ago, when we started doing these experiments, we really just didn't know whether music would have the same sorts of effects. And lo and behold, it does. So we were able to show via a series of different brain imaging studies that when people experience music that they really enjoy, that really is very positive emotion for them, the reward circuit is definitely active. And so that set us on the path to try to address the question you were posing, which is, why does that happen? So the first step was to figure out, is it based on the same biology, the same biological mechanism that we all have and that we share with other species, by the way? Um, and the answer seems to be yes. And we even showed, using some special neuroimaging techniques, that dopamine is involved. So when you do
Mm.
experience pleasure from music, dopamine is being released in your reward system.
And I would, I'm assuming here that this effect is universal. Like, I mean, when I think about music, music is universal, right? You find music in every culture. And so would that
Yes.
pleasurable effect be universal as well among humans?
Well, we presume so because
Mhm.
the reward system is not only universal in humans; it's universal in all kinds of species, right? So if you
Right.
look at the anatomy and physiology of the striatum, for example, which is one of the main structures in the reward system, the one in a rat and the one in a person look pretty similar, even though we're 100 million
Yeah.
years away in evolution. So clearly, it's something very, very widespread. Now we need to do more investigation to figure out how different cultures exploit different patterns of sounds in order to reach the reward system, because it's very clear that each musical culture, and even within a culture, different subgenres, even within Western music, for example, Western music has everything from jazz to pop music to opera. Those are all Western musical styles. But someone who really likes one is not necessarily going to like the other.
Right.
They
Yeah.
might
So
or they might not.
do we know anything about that? Because that is curious. I mean, why is it that you, for example, you just love Bartok, you got enormous pleasure from it. Someone else may listen to it and say, "Oh, I hate Bartok. How can he listen to that?" And then of course, yeah,
Yes.
you've got people who like pop, others like classical, others like jazz. Do we know anything about that? About these preferences?
Yeah, we do know some things about that. So exposure and adolescence. So if you survey people about their musical preferences as adults, you will find that the majority of people will report that their favorite style of music is whatever was popular during their adolescence.
Mm.
That has been shown a number of times. It's not only what was popular during their adolescence, but that'll be a big part of it. There's a secondary effect of the music that you were exposed to during childhood. So the music that you like most is the one that was during your adolescence, but maybe a secondary preference will be what was played to you as a child. But if you think about that, what you were played to as a child is what your parents liked, and what your parents liked is what they heard during their adolescence,
Right. Yes.
right?
Oh my
So
goodness.
it's like
This is a
the second
continuous cycle.
generation.
Yeah.
It's a continuous cycle, yeah. So to give you my own personal example, uh, I was born and grew up in Argentina, and my parents, were born in the 1920s, and so during their adolescence was the peak of the tango culture. They loved tango. They danced tango, well into their old age. They were always dancing tango. So we heard a lot of tango at home. And when I was a kid, I was like, tango, I don't know, didn't do anything for me. But then, as a young adult, I started to rediscover it, and because I had heard it, and because it's sort of culturally significant to me and reminds me of my parents, reminds me of when I was young. Um, it's something that I like. So uh, my Spotify account is extremely confused because it tries to give me contemporary classical music and tango and organ music because I'm an organist, and so it doesn't really know what to make of me. I don't fit into any of their categories.
You know what though? What I find so interesting about what you're saying, um, if it was purely just the music that we were exposed to as children or young people, let's say, and that would be the music that our parents like, and then they like the music that their parents like, then nothing would change, right? But there must be something in human nature that we seek change. We want to
Yes,
seek something different. Something novel that we're turned
absolutely,
on by some, right? And that's why we have changing
absolutely.
music.
Yes. So there are several other factors that play a very important role. One of them is what you've just said, which is the novelty seeking. And in fact, that term, novelty seeking, is an established term in psychology, and it refers also to a personality trait. So there is a personality trait called novelty seeking, which varies from person to person. We all have it to some extent, but some people have like an extreme version of it, and some people are more conservative and have a less of that. But that plays a big role. And if you look at any art in any culture, you see that it evolves over time, and that's also related to another concept, which is that um, when we have experienced a piece of music or some other kind of art, we may appreciate it a lot, but after you've heard that particular style enough times, you it starts to become a little bit too predictable. And that's where the novelty comes in. So you
Hmm.
need to get your reward system active, you need some surprise. This is really very important. It goes back to what I said at the very beginning that the reward system is not only responsive to an actual reward, but also to the anticipation of what will come next. And so
Yeah, that
that
makes total
anticipation
sense.
needs novelty, needs a bit of surprise,
Right.
not too much surprise. So novelty seeking is important as a individual trait. And so, why do some people like certain genres? Well, also it depends on their personality. So if you are more of a sensation seeker, or someone who likes, exploration, you will probably prefer something quite unusual, which is probably, that's probably my personality when I was younger. That's why I liked this unusual new style of music, because it satisfied something in me that the other kind of music wasn't satisfying. The other kind of music was kind of, repetitive, and
Hmm.
it wasn't doing it for me. Um, but it might be, for other people who don't like too much novelty, it might be fine for them. And I'm not
Yeah.
making value judgments, because I'm a scientist. I'm not a culture critic. So people often ask me, well, what's the best music? And it's like, well, it's not up to me to judge. It's up to you to judge. Um, and then a further factor is your own musical enculturation. So the more you study music, the greater your capacity will be to understand more complicated musical patterns. And that's true in any genre. So if you've never studied jazz, you may have trouble figuring out what, John Coltrane is doing, right? Because what he's doing is at a very high level,
Mm.
and it doesn't just come to you like that. But if you study jazz, and you work with maybe teachers who know that style, and who are able to tell you, well, here the theme is being transformed this way, or this chord progression has this structure, that helps you understand.
I want to go back to the whole idea of music and emotion and just explore that a little further. Because, we talked about you listening to the bar talk and feeling pleasure, right? You felt good, you felt joy. Is there something about music? Well, there is something, and I guess I need to know, what is it about music that can not just fill us with joy or happiness, but it can make me feel sad, right? It can make someone feel
Sure.
sad, or it can make someone feel aroused or restless, or, I mean, depending on the kind of music we hear.
Hmm.
So, what's the connection there with
Yeah.
music
So
and different emotions?
that those are excellent questions, and they're active research questions, I would say. There are a lot of people, our lab included, who are really actively working on that, because it's both a very interesting question, but also a question that has many different sort of aspects to it. So there's not a single answer. There's going to be many answers. But I can tell you about some of the answers that are coming out. So you're absolutely right that music can evoke quite different emotions, um, and you can distinguish between pleasure and the emotion that you're feeling. So you might have a very pleasurable, um, excited, joyful feeling, or you might also have a very pleasurable but subdued, even sad feeling. And music, part of the reason music is powerful is because it isn't just about one thing. It isn't only to explore joy. It's also to explore all kinds of other emotive states. Now, how does music achieve that? In many different ways. One really interesting phenomenon that's been studied recently is that there seems to be a link between movement and the sound that's produced by the movement and the emotion that that sound generates. So let me explain. First of all, one important thing to realize is that all sound is the product of movement. You can't have sound as something that didn't move, because sound is made up of airwaves that are being compressed and that reach your ears. But something has to compress the airwave, so it means something moved, right? If I do this, you hear the sound.
Right.
If I don't move, you don't hear any sound. So, um, so sound and movement have this sort of physical connection. But then beyond that, what's very interesting is that if you look at the movement profiles that are associated with different emotional states, and then if you look at the sounds that would be produced by those movements, you see this very interesting connection. So if you are very happy, if I tell you that you just won the lottery, you will be very excited. What will you do? How will you move? You'll be jumping up and down, right? You'll be moving really quickly. You'll be shouting. You'll be telling all your
Right.
friends,
Okay.
right? Whereas if I tell you that, oh, sorry, your cat was run over by a truck, you're probably going to be, moving very slowly. Your voice will be modulated downwards. Um, your movements will be not jumpy, but sort of smooth. There'll be low amplitude. You won't be moving a lot. You'll be moving very slightly. And people have actually done experiments where they basically sonify those kinds of movements that are associated with different emotional states. And the sounds that are produced, you know, sound happy in one case and they sound sad in the other. And when you look at music that people say, oh, this is a happy tune, this is a sad tune, it has some of those same characteristics.
Okay, hold on. I've got to understand this. So
Yeah.
you said they sonify it. This sounds as if though there might be some subjective interpretation in how that movement corresponds to sound. Like how do you really know? Do you know what I mean? Once you put that into
Well,
sound, is it the
yeah,
beat? Is it because there's a more of a rapid beat to represent the happiness and it's slower? But what
yeah,
about the actual cadence, the chords? Like I don't
sure,
quite understand. Yeah.
sure. Well, there are several acoustical parameters that are the link between the sound and the movement, and beat is certainly one of them. You can actually do experiments, for example, where you take uh, an image on a screen, like just a ball, for example, and you ask people to adjust it to make the movements correspond to happiness, and you ask them to adjust different parameters like speed and size of the movement and how jerky it is and so forth. And then you take that and make that into a sound, and you ask other people, does this sound happy or sad to you? And there is a correspondence. And when you tell this to musicians, they often will say, well, yeah, duh, of course we know that.
And so
When
so
I
would
write
there
a sad song, that's what I'm doing,
yeah.
right? I'm transmitting this emotion, and there is a part of it that's movement. Another part of it, which is also somewhat related to movement, is the sound of the voice. So the human voice transmits emotion independently of music, right? You can tell right away from
Right.
someone's voice if they're happy, sad, if they're angry, if they're
Mhm.
scared. It's really pretty obvious. So if you look at the acoustics of the voice, you will find that there are certain features of the sound that are associated with happiness or with sadness, or with fear or with anger. And when you translate those into the sound of an instrument, guess what? The instrument will sound happy or angry or whatever.
So can you just I just need an example then. Can you give me an example of what would be considered then a happy, generally speaking, a happy song based on these principles of movement and
Hmm.
voice or the sound?
Sure. So it would probably be um, a sound that has a bright timbre. So that means that it has energy in the upper frequency ranges, the upper harmonics of the sound. It would probably be fast. So speed is one of the most important features.
Mm,
It would probably involve some tonal leaps. So it wouldn't all be just like, you know, a
the same
small
notes.
excursion. It wouldn't
Right.
just be like two or three notes. It wouldn't be just like dee 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 dee. It would probably be dee 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 doo doo doo. If you put all those things together, it will generally sound to people as if it's happy.
And the sad piece of music would be then the opposite of the happy, slower,
Yes,
a
it would be
lower
slow.
key.
It would be slow. It would tend to be a darker timbre, so
Mhm.
less energy in the upper harmonics. It would tend to be smoother transitions, so no jumps or fewer jumps. It would also be softer. I didn't mention earlier, but happy music is loud music, right? Or loud music is happy music. Generally, not always. It can
Uh-huh.
be scary too. Um, but sad music tends to be soft because when you're really sad, you're not shouting, right? You're whispering. Think of people at a funeral. Is
Uh-huh.
anyone shouting? No, right? They're all talking in very hushed voices because they're upset. They're sad.
And this tends to be universal. Is that right? Cross-cultural.
Yeah, there are
Yeah.
some studies. There are some studies that show that these features are not all of them, and not in every culture, but they are definitely found across many, many cultures. So there must be something that explains it. Now, what you have then is a cultural overlay. So these features that I mentioned probably are, in some respect, universal, or at least cross-culturally used. The word universal is tricky, um, but that doesn't mean that they're always expressed in the same way or to the same extent. So a particular culture may choose to emphasize some features and not others. Certain cultures may add other features that are purely learned, that are not that are not universal. So you could very well imagine
Hmm.
that um, the sound of a particular instrument, if it's used in a given culture, if a certain instrument is only brought out uh, for funerals because that's the tradition, then every time you hear that sound, people will think it's mournful,
Right, from the
right?
association. Yeah.
But that's an
Yeah.
association.
Right,
But you
right.
could easily imagine how that would certainly be the case.
What
Um,
what what about, because I've always been interested in this too. What about chords? Because when I
hmm,
think about happy songs, I think usually they're in a
hmm
major chord, and that
hmm
sad songs or even scary
hmm
songs could be in a
hmm
minor chord. Now,
hmm
how cross-cultural is that?
Yeah, that's a very tricky question to answer. There's some evidence that suggests that it's not completely arbitrary, that there might be some features of major and minor chords that do convey that emotion. There's other evidence that suggests that it's really just a learned association, and there's not more to it than that. Um, it it's probably some of both is my guess, because it seems unlikely that it's completely and utterly random, but it's also unlikely that it's completely um, universal across all cultures, because some cultures don't even have major and minor scales at all. So the other thing I was going to say is that another feature that's important is dissonance and consonance, and that might be also related to vocalizations, like I said before. So dissonant sounds usually, but not always, will tend to sound more negative. And again, there's some discussion in the research community about whether that is entirely learned or not. Um, but it seems odd because it can't be entirely learned. Learning influences and changes the culture that you're in, completely changes the way you might perceive it. But um, it seems like you start off with a similar response. So, for example, infants will prefer, if you test them in certain ways, they will show a certain preference for more consonant sounds over more dissonant sounds.
Oh, they
So that
will.
can't, yeah, so that can't be
Oh,
explained by what they've learned, because they haven't learned much
that's
yet.
right. So infants
However,
tend to,
later
yeah.
they will learn, and they may end up liking really dissonant music.
So when you say they prefer those sounds, would they be considered more harmonious sounds as well?
Yes.
They are. And so then where would lullabies fit into that?
Yeah, so lullabies are a good example, because one feature we haven't talked about too much is arousal, but it's related to the happiness and sadness, and to the other parameters we were talking about before. So you can have low arousal music, which is not sad, but it is soft and calming. And it's not just babies that like lullabies; adults like it too. And in fact, we know that the lullaby, in particular, really does seem to be cross-cultural, because some colleagues of mine did a really interesting experiment. They recorded lullabies in like 21 different cultures all over the world, in in Papua New Guinea and in northern Finland and in South Africa and so on. And then they asked other people who weren't from those cultures to indicate which of several different styles was a lullaby. So which was a lullaby and which was like a love song and which was like a dance song. And people can do that. In other words, even though I've never heard music from Papua New Guinea, I can usually tell, well, which one is a lullaby. And it's not because I speak the
Mm.
language either, right?
Mm-hmm.
But it's because there are some features of lullabies that are very common. And why is that? Because mothers everywhere on the planet, when they sing a lullaby, they want the kid to finally stop fussing and to go to sleep, right?
Right.
And there are certain sounds that the baby will respond to that will cause it to at least calm down and usually eventually to fall asleep. And those are not loud sounds. Those are not, you know, super rhythmic sounds. They tend to be low amplitude, in other words, soft,
Mm-hmm.
maybe with a very sort of constant, gentle rhythm, not with big jumps not big jerks in the melodic contour, and so on and so forth.
Are lullabies generally, are they in a major or a minor key?
They don't have to be in either, actually. I
So you know
don't think.
they're across the board. They tend to
I
be,
I
they're also
believe
in.
so. I believe I have not looked at the surveys, so I can't answer your question for sure. But I don't believe that it is necessary for them to be either major or minor to be
Yeah,
a
the
bona
reason
fide lullaby.
yeah, I'm so curious though about the whole major minor thing because I was thinking, well, if there might be some evidence that supports that, if we like I was thinking of nature. I mean, how much of the sounds or so-called music that we hear in nature influences us on a very sort of primal level as to what we think music is, what makes us happy, what makes us sad. I mean, do we know whether there's perhaps a relationship with songbirds, for example? Um,
Mm.
and how they sing, and are they singing in a major chord or a minor chord, or what is it about the way they sing? Because they make us happy, right? We
Yeah,
associate bird.
so I think that's an association because generally, when you hear songbirds, uh, you're in a pleasant spot, you're surrounded by nature, maybe you're calm, etc. But for one thing, birdsong doesn't really correspond to human scales. They have, very different sounds. In fact, they don't always make tonal sounds. They use screeches and
Mm.
and all kinds of sounds that are not really part of uh, tonal structure. Um, and furthermore, what I think is interesting about songbird is that we always think of them as music, but that's how they sound to us because we're listening to it with our human brain. I don't know what it sounds like to the bird because the bird is listening to it with the bird brain.
Right.
That's what it was intended for.
Right.
And like a really good example is, birds will often sing to defend their territory, right? So we're listening to the bird and going, "Oh, isn't that pleasant? It's such a nice little song." And the bird is going, "Get out, get out! This is my tree. Don't even come near me. I'll kill you if you come anywhere near me." That's what they're saying. But we
Right.
go like, "Oh, no, no, it's so nice." So we're not really getting the message that the bird is intending, right?
Mhm.
Because we don't have the capacity to decode their particular message. And so I think it's a little bit naive to think that birdsong is really that similar to human music.
Mhm.
Um, Nonetheless, it's still it's an active area of research where people study birdsong, and it's super fascinating to learn how it is that the bird brain is able both to produce and to perceive um, the songs that they use for communication.
Right, right.
So that
So
teaches us something about the biology of of human, excuse me, the biology of animal communication, which is kind of, in a sense, a
mhm.
foundation, because you could think of music as a very special elaboration. I think of it as a species-specific elaboration of um, animal communication.
Mhm.
So
Do
I always think humans have two ways of communicating via the vocal auditory system. One is what we're doing right now, which is talking, and the other is music.
Mm. I was talking to someone about this interview. They were really interested in it, and they said, "Why is it?" They said, "You have to ask Robert this question. Why is it that music, he felt, above all other art forms, provokes us to move?" And I don't know if
Mm.
it has something to do with what you said earlier about,
Hmm.
sound is movement, but he was thinking
Hmm.
about it and he said, I can read a great book. I can look at a painting. I can go to theater, see some performance art, but it doesn't necessarily make me want to move or dance. But music
That's right.
does that. And I thought
Yes,
he's right.
exactly.
That is so true.
Yeah, yeah, yeah. That's a very important phenomenon that a lot of people have been studying, because it really does seem to be something that music evokes. And it's not even other rhythmic movements, because sometimes people say, oh, it's just rhythmic movement. But if you sit and watch, let's say, a tennis game, it can be very rhythmic, right? The ball is going to
That's
tuk,
true.
tuk, 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 but no one gets up in the stands and starts dancing.
Yeah, right.
It doesn't make you feel like dancing. So in fact, there's a phenomenon that is known in the scientific literature as groove, which we stole from the musicians. And groove specifically refers to the pleasurable sensation of wanting to move to rhythmic music. And it's been studied a fair bit. And one of the findings is indeed related to what I said before, which is that there's this intimate link between action and sound. So if you are moving in a rhythmic way, you will very often be producing sound in a rhythmic way. And that sound is transmitting your movements to the other person, even if they can't see you, right? You know how
Hmm.
the other person is moving. And so then there's almost a mimicry that can occur where the other person will want to start moving in synchrony with you because you're communicating, right? You're exchanging information. So that's a big part of it. There's also a very interesting physiological counterpart of that, which we studied with our brain imaging techniques, and that is that when you present music that has a certain rhythmic structure to people, and we're looking at their brain activity, we of course see the parts of the brain that are auditory. In other words, the parts of the brain involved in hearing, they are of course active. But what we also found is that there are other regions up here which are in the motor cortex, which are also active, even when we have people sit absolutely still. So they're listening to the music, they're not moving anything, not even an eyebrow. Um, but we see the motor parts of their brain that are active. And this happens when the music is well structured. In other
Huh.
words, when it has a metrical organization, when there's a beat structure to it. And so that means that there's a strong coupling between the motor parts of the brain and the auditory parts of the brain. They're talking to each other.
So you
And
mean to
that
say that
is,
that is that part of the brain move or that part of the brain reacting as if they were actually moving?
yes, that's exactly right. So this
Huh.
is this is the part of the brain that would normally be active when you really are moving. So we can test that because we can obviously have people move. We can see
Yeah.
which part of the brain is active. Then we have them listen to the music, and we look at that same bit of brain, and we see that it's also active, usually to a lower extent, but it's still active, um, even though in the absence of movement. And this doesn't happen with other like visual stimuli
No.
or verbal stimuli. Like you were saying, you can read a story, even if the story describes a lot of movement, it still won't make you want to move.
That is fascinating. That and some of the other things that you said, it makes me wonder about the therapeutic aspects of music. Like where can we take all this knowledge, and it how is it changing the brain? And can
Yeah,
it permanently change the brain in good ways? If
yeah,
someone is ill, or if someone's health needs to be improved in a certain way, well, what is the role of music?
indeed. So there's a big push right now um, to take this knowledge that we've been able to obtain from doing the science and using it applying it in different situations, including to clinical populations. And I always say this, that it's important to realize, how do you get to therapeutic interventions? Well, you get to it by doing the basic science first. Because for years, people would sometimes ask me, "Well, why are you studying music? That's pretty useless. You're wasting your time. You're wasting money doing these experiments." Um, and my answer is always, well, it's curiosity. It's what we do as humans. We explore our universe and we try to understand it. And that's what science is about. But thanks to that knowledge that we can generate, then we can actually use it in different settings. And so there's a lot of work now being done. In fact, one of my former students, Joyce Chen, is a professor at University of Toronto right now, and she's using this link between music and movement in stroke rehabilitation. So people who have a stroke, who
Ah.
have trouble moving their limbs, you can use sounds to facilitate their movement as part of a therapy, as part of a physiotherapy to help them regain some of the function. So that's one example.
Okay,
Other
sorry. Let
labs are
me just ask
also.
you. Can I just ask
Yeah.
you? So, are you saying
Yes.
it is what you were talking about before, that when these people are listening to the music, even though because of the stroke they may not be able to move in the way they did before, that part of
Mhm.
the brain is reacting as if they were moving, and that could be maybe the beginning of some kind of rehabilitation
That's what
towards
people are.
movement,
That's what
or
people are working on, is the fact that the music seems to facilitate
yeah.
the activity in the motor system, even in the absence of movement. Because of that, we can then try to figure out, can we uh, can we capitalize on that phenomenon in the context of a therapeutic
Mhm.
intervention to enable movement when it's otherwise difficult or
Mhm.
impaired. And that's just one example. There's also examples in, for example, in gait. So people who have gait problems, like patients with Parkinson's disease, there are a lot of different groups
Right.
that are trying to use music and
Yes.
dance, in fact, as an
Yes.
intervention for Parkinson's. Um,
Also,
and
even
there
with
are,
Alzheimer's patients, no? Isn't there music
yes,
and being studied with Alzheimer's patients and its
indeed,
effect?
there are a lot of people working on music and Alzheimer's. Also because of all of the research we were talking about earlier on the reward system and the pleasure that we get. So in many conditions, in dementias, and in clinical depression, also in Parkinson's to some extent, um, patients often have a mood disorder. So they're unhappy. They're
Mhm.
not doing well, and so there are people who are trying to use music as a way, again, to engage the reward system so that they can better uh, respond to the world around them. And that's a very active area of research. Actually, I have a collaboration with a former student of mine, Naomi Singer, who's now in Tel Aviv. And we're trying to do an intervention with patients there who are depressed, due to Parkinson's, to see if we can use music as neurofeedback. So as soon as they hear the music, the reward system is active, but then we have a special way of detecting the activity of the reward system, which makes the music sound even better. So then they hear it and it's
Oh.
even more rewarding, and it's like a positive feedback loop. So
Huh.
that's another approach that people are working on to try to harness the power of music, in clinical settings.
Yeah, and it's drugless. And it's
Right.
non-invasive. It's not like there's any surgery or
It's
pill
non-invasive.
involved.
There's no drug, and it's also
Yeah.
super cheap.
Yeah,
And
right.
right, it costs nothing, and you can.
Yeah.
It's the kind of thing I hope in the not so distant future there'll be all kinds of apps that you could download on your phone and
Mm.
use them, for different
Mhm.
kinds of therapies, um, that would be effective, or at least that could be used in conjunction maybe with more traditional therapies that might include pharmacology or might include traditional physiotherapy, but you can maybe help that along via music. So
Yeah.
this is a very
Very
interesting thing.
exciting.
The NIH is actually sinking a few $1 million into this. I'm going to San Diego next month to speak at the Society for Neuroscience at an NIH-sponsored symposium on the use of music in therapeutic interventions.
Oh, wow.
So
Hmm.
yeah, so I think this is a real thing that
Yeah.
that is coming along, and we'll see how far it goes. Some of those approaches may fail, others will succeed. We don't know yet. It's still very, very early days,
Hmm.
but it's super exciting for me to see
Hmm.
that the knowledge that we generated through our basic science now has these very interesting, potentially groundbreaking applications.
Someone said to me the other day, and she's an artist, and a brilliant artist in many different art forms. She's a poet, a writer, a filmmaker. Yeah. Anyway, she's done so much, but she said to me that she thinks music is the highest form of art. Do you
Hmm.
think so?
Well, I'm biased.
Well, we know that. We know that, but
Of
you can
course,
still
I
have an
think that,
opinion.
but yes, I have an opinion that, of course, it's if I had to choose amongst various arts, I would reluctantly give up on visual art and so on. I think speaking for myself personally, I think I would agree with I think it was Nietzsche who said, or maybe it was Goethe who said, life without music would be a mistake.
Oh, yeah, right.
Yeah,
Hmm.
pretty sure it
Yeah, I
was
can't
Goethe
remember, but I've heard
who
that. Yeah,
said
I've
that.
heard that
I
quote.
think I think so. So sure, but we don't have to choose, right? The beauty of art is that it's all around us, and we can benefit from it in every form, and sometimes they even enhance each other.
Hmm. Really enjoyed this discussion, Robert. Thank you so much for enlightening all of us
Thank
about
you.
music and its many potentials.
Thank you very much, Mary. It was a real pleasure.
That's Robert Zatorre. He is a cognitive neuroscientist at the Montreal Neurological Institute at McGill University. For more information on his work, please check out our show notes. That is it for this edition of the Cram Podcast. We hope you enjoyed it. And our thanks to the Temerty Foundation for their generous support. You might also be interested in our literary podcast. It's called Passage to Wonderland. I highlight compelling passages from books that offer discovery, insight, and a sense of completion for the end of your day. You'll find Passage to Wonderland wherever you get your Cram podcast. Thanks for joining us. See you next time.